A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Do you remember what we studied in the previous session? Yes. We have learned about two types of current, AC and DC. Like this, there are two types of generators, AC generator and DC generator. Now, we are going to discuss an AC generator. This is the working model of an AC generator. Let's see what are the important parts. Armature is one of the main parts in a generator. We have studied that it is an arrangement where insulated copper wire is wound over a soft iron core. The armature sits in between two powerful magnets and that can rotate freely about an axis. This is the north pole and this is the south pole. We know that the electric field lines are always from north pole to south pole. These magnets create a strong magnetic flux inside the generator. Slip rings are the other important part of AC generators. These rings are finely touching the graphite brushes. But it is very important to note that the brushes and the rings are not connected together. Let's see how an AC generator works. This is the 0-degree position of the armature coil. We know that the magnetic field lines are from north pole to south pole. In this position, the magnetic field lines are parallel to the armature coil and hence field lines are passing through the armature without getting interrupted. So, there is no change in flux and hence the induced EMF and current is 0. After a 90-degree rotation, the armature coil aligns at this position. Here, the magnetic field lines and the armature coil align in a perpendicular direction. That is, armature is cutting maximum field lines. So, the change in magnetic flux will be maximum and hence the induced EMF and the current will also be maximum. CD is now facing the north pole and it is rotating downwards. So, a current is induced in the respective direction and the direction is said to be positive. After rotating further 90 degrees, the armature aligns at an angle of 180 degrees. The position is similar to the 0-degree position. That is, armature coil is parallel to the magnetic field lines. So, there is no change in flux and hence no induced EMF and current. Armature rotates through another 90 degrees and aligns at 270-degree position. This portion, which was facing the north pole before, is now facing the south pole. Here, the magnetic field lines and the armature coil aligns in a perpendicular direction. That is, the armature coil is cutting maximum magnetic field lines. So, the change in flux is maximum and hence the induced EMF and current are also maximum. When you observe, we can see that at a 90-degree position, the CD was moving downwards and hence the direction of induced current was considered as positive. But when it comes to 270-degree position, CD is moving upwards. That is, the direction of motion is reversed and hence the direction of reduced current is also reversed. This is considered as a negative direction. The armature again rotates another 90 degree and aligns at 360-degree position. This is similar to the initial condition and 180-degree condition. Armature and the magnetic field lines are parallel and hence there is no change in flux, no induced EMF and no induced current. Here we can say that the armature has completed a full rotation. The current induced here is flowing through the external circuits through rings and brushes. We can use Fleming's right-hand rule to determine the direction of induced current at 90 degrees and 270 degrees. Let's consider the 90-degree position of the armature. Here, we can see the points A, B, C and D. Let's apply Fleming's right hand rule here. We know that the direction of magnetic field lines are always from north pole to the south pole. So, stretch the forefinger in that direction. The CD is rotating downwards. So, stretch the thumb downwards. Then the direction of the middle finger, which is perpendicular to both the fingers, give the direction of induced current. That is, at the point the current is flowing from CD to the slip ring R1 to B1 to the external circuit to B2 to R2 and then to AB. Now the armature rotates from 90 degrees to 270 degrees. This is the 270 degree position of the armature. The CD is rotating upwards. Let's use Fleming's right hand rule here. We know that the direction of magnetic field lines are always from north pole to the south pole. If we stretch the forefinger in this direction and thumb to the upward direction, the direction of the middle finger, which is perpendicular to both the fingers, give the direction of induced current. That is, at this point, the current is flowing from C to D to the ring R2 to B2 to the external circuit to B1 and to the ring R1 and then to AB. Here, in the first half of rotation of the armature coil, that is from 0 degree to 180 degree, current was flowing from B1 to B2. This direction is considered as positive direction. But in the second half, that is from 180 degree to 360 degree, current was flowing from B2 to B1. That is in the opposite direction. So, it is called a negative direction. One full cycle consists of one positive half cycle and one negative half cycle. The number of cycles per second is termed as frequency. In power plants, AC generators are designed in such a way that it makes 50 full cycles, that is 50 full rotations in 1 second, which means the frequency of AC generated here is 50 Hz. At 90 degrees and 270 degrees, the maximum current is produced. But we can say that at 90 degrees and 270 degrees, the direction of induced current was opposite to each other. So, this type of current which changes its direction is called alternating current or AC. The generators which produce AC are called AC generators. Here, the upper part of the graph shows the positive direction in the first half cycle and the lower part shows a negative direction in the next half. We learned how generator work and how they generate electricity. One thing we should keep in mind, the generator converts the mechanical energy we supply into electrical energy. This is the energy change happening here. How do we supply mechanical energy? We have various possibilities like using the power of wind and water. In vehicles, generators are rotated using fossil fuels such as diesel and petrol. So, in this session, we have learned the working of an AC generator and the energy change involved in it.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.